Hi students, welcome to Sankalp Study Success. Today in this video, I am going to start Engineering Mathematics 1, that is M1 for first year first sem students. Okay, before going to start the class, let's have a look into the syllabus of first unit matrices. And this syllabus of M1 is common to all branches of engineering. The syllabus is same. Okay, coming back to the syllabus of first unit matrices. The first topic is rank of a matrix by echelon form and normal form. That is, we have to find the rank of matrix using these two forms, echelon form and normal form. This echelon form is based on the concept called as upper triangular matrix. Okay, next, normal form. In this normal form, we will reduce the given matrix into identity matrix and we will find the rank. Okay, next topic is how to find the inverse of a matrix using Gauss-Jordan method. And the third one is, we know there are two types of linear equations we have already seen in intermediate. Okay, that homogeneous and non-homogeneous equations. How to solve these two linear equations by using Gauss elimination method. That means we are going to test for the consistency, that is whether the given system of linear equations is consistent or inconsistent, making use of this Gauss elimination method. And the last topic is Gauss-Seidel iteration method. Now let's start the class. The first one is Introduction to Matrices. From this Introduction to Matrices and types of matrices, few questions have been asked in the previous year question papers. Okay, so what is a matrix? A matrix is a rectangular array of numbers with m rows and n columns. The order of the matrix is given as m by n. See here students, this is called rectangular array and we will arrange the elements inside this rectangular array as a11, a12 up to son a1n, a21, a22 up to son a2n, and the last element will be amn. Okay, where a11 is the element that belongs to first row first column, a12 is the element that belongs to first row second column, and a1n is the element that belongs to first row nth column. And in the same way, we will define the last element, that is amn, as mth row and nth column. Now coming to the order of the matrix. The order of the matrix is given as m by n, where m is called a number of rows and n represents the number of columns. Now let's see here students. Okay, in the first example, this is the first example. We shall find out the order of the matrix for this example. Okay, this is R1, R2 and R3, and this represents column 1, column 2 and column 3. So here it has 3 rows and 3 columns. Therefore, the order of the matrix is 3 by 3. Whereas coming to the second example, see, this is R1, R2, R3, whereas we have only 2 columns C1 and C2. Therefore, the order of the matrix here it is 3 by 2. Now coming to the third example, here it is R1, R2, but we have 3 columns C, C1, C2 and C3. Therefore, the order of the matrix is 2 by 3. So this is how we have to find out the order of the matrix based on the number of rows and number of columns. Now coming to the next topic, that is types of matrices. The first one is square matrix. A square matrix in which the number of rows and columns are equal, then we call it as a square matrix. If m is equal to n, that is number of rows is equal to number of columns, then we call it as a square matrix. Okay, here in this example, first example, this is R1, R2, this is column 1 and column 2. So we have 2 rows and 2 columns. That means m is equal to n is equal to 2. This is a square matrix. Now coming to the second example, this is R1, R2, R3, and also we have 3 columns C1, C2 and C3. Therefore, the order of the matrix here it is 3 by 3. What does it mean? It means that m is equal to n is equal to 3. Okay, this is a square matrix. Now coming to the third example, there is only one element inside this rectangular array. So what does it mean? It has 1 row and 1 column. M is equal to n is equal to 1. So it is a square matrix. Even we can have 4 by 4, 5 by 5, 6 by 6, 7 by 7. All these are called as square matrix because m is equal to n. Now coming to the second type, row matrix. A matrix of order 1 by n is called row matrix. That means it has only 1 row and n columns. The matrix which has only 1 row and can have any number of columns is called as row matrix. Here see students, we have only one row and we have three columns here. Okay, so the order of the matrix here it is 1 by 3. Okay, this is called as row matrix. Next, coming to the column matrix. Column matrix is nothing but a matrix of order m by 1 is called column matrix. That is, it has only one column and can have any number of rows. Coming to this example, see here students, we have 3 rows here but only one column. So what is the order of the matrix? It is 3 by 1. In this case, we have only one column and 3 rows. So it is called as column matrix. Only one column it should have and it can have any number of rows. Now coming to the next type of matrix, it is diagonal matrix. Diagonal matrix, let's see the definition. A square matrix in which all elements except those in leading diagonal are 0 is called diagonal matrix. Let me simplify this sentence. It is nothing but the diagonal, except the diagonal elements, the remaining elements are all 0 except the diagonal elements. Okay, if you can see here in this example, these are called diagonal elements. Okay, and the line along this diagonal element we call it as principal diagonal. Okay, principal diagonal elements. So, and the remaining elements all are 0. That is called as diagonal matrix. The diagonal elements here are 3, minus 1 and 2, and these diagonal elements should not be equal to 0. Otherwise, it is not a diagonal matrix. Is that clear? Now coming to the scalar matrix. A square matrix in which diagonal elements are same is called scalar matrix. Diagonal elements should be same and the remaining elements should be 0. Okay, see here the diagonal elements 3, 3, 3. It is called a scalar matrix and the remaining elements are 0. The diagonal elements should be same. It can be either minus 1, minus 1, minus 1. I will write down another example of a diagonal scalar matrix here. A is equal to like minus 5, 0, 0, 0, minus 5, 0, 0, 0, minus 5. See, if you observe carefully, all the diagonal elements are same. All the diagonal elements are same and the remaining elements are zeros. Now coming to the identity matrix. Okay, a square matrix in which the diagonal elements are 1 and the remaining elements are 0. The diagonal element should be 1 here. The diagonal element should not be 2, 3 or 4 and any other. It should be 1 only. And the remaining elements, see this is the remaining elements. The remaining elements should be 0 here. Is that clear students? It is a 3 by 3. This is a 3 by 3 identity matrix. This is a 3 by 3 identity matrix and this is a 2 by 2 identity matrix, that is 1 0 0 1. Now coming to the trace of the matrix. Sum of the principal diagonal elements of a square matrix is called trace of matrix. Sum of the principal diagonal elements, that means we have to add the principal diagonal elements. What are the diagonal elements here? 2, 5, 7 are diagonal elements. So I will add all those 3 elements, that is 2 plus 5 plus 7, which is nothing but 14. 14 is the trace of the given matrix. Now coming to the triangular matrix. Triangular matrix is of 2 types, upper triangular matrix and lower triangular matrix. Coming to the upper triangular matrix, a square matrix in which the elements below the principal diagonal are 0. Below the principal diagonal are 0 is called as upper triangular matrix. See, this is the principal diagonal if you can see, and below that principal diagonal all the elements are 0. This is called as upper triangular matrix. Now coming to the lower triangular matrix, a square matrix in which the elements above the principal diagonal are 0. In the case of lower triangular matrix, the elements above the principal diagonal should be 0. Yeah, here is the example for you. So this is the principal diagonal and the elements above the principal diagonal are all 0. That is called as lower triangular matrix. Next, coming to the transpose of a matrix. Transpose is nothing but interchanging the rows and columns, that is called as transpose of a matrix. That means we have to write down the rows as columns and columns as rows. Okay, we will represent it as A transpose or A dash. For example, here the matrix is given as 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I will write down A transpose for this. Okay, what is the first row? First row is 1, 2, 3. That I will write down as a column here. 1, 2, 3. Next, second row is 4, 5, 6. That will become the second column. 4, 5, 6. I should write out as a column. And the third row is 7, 8, 9. That I will write it as a column here. So this is called as A transpose. That is interchanging the rows and columns. Now coming to the symmetric matrix. A square matrix is said to be symmetric if A is equal to A transpose. A is equal to A transpose. That means even after transposing the matrix, that is even after interchanging the rows and columns, I should get the same matrix that is given in the question. Okay, here the example is A is equal to 5, 1, 2, 1, 3, 7, 2, 7, 8. I will write down A transpose first. Let me write down A transpose. What is A transpose? First row is 5, 1, 2. Though that I will write it as a column. Second row is 1, 3, 7. I will write it as a column. And third row is 2, 7, 8. Write down it as a column. Okay, now see, if you observe carefully, we can say that A is equal to A transpose. See, I will explain. See here. See, this is 5, 1, 2. Here it is also 5, 1, 2. Here 1, 3, 7. Here it is also 1, 3, 7. Here 2, 7, 8. Here it is also 2, 7, 8. So even after interchanging the rows and columns, we are getting A is equal to A transpose. That is called as symmetric matrix. Okay. Next, skew-symmetric matrix. A square matrix is said to be skew-symmetric if A is equal to minus A transpose. We should get minus A transpose. Okay, let me explain here. So this is the example: 0, 1, minus 2, minus 1, 0, 3, 2, minus 3, 0. Let me write down first A transpose. Okay, what is the first row? It is 0, 1, minus 2. I am writing out as a column. Second row I am writing it as a column. And third row 3, 2, minus 3, 0. Yes. Okay, so this is A transpose. Now here if you observe carefully, here it is 0, 1, minus 2. But here it is 0, minus 1, 2. Here it is minus 1, 0, 3. Here it is 1, 0, minus 3. 2 minus 3 0 minus 3 minus 2 3 is 0. That means I will multiply this A transpose with a negative sign. Okay, I will multiply this, that is minus A transpose, with a negative sign. So minus of what we have got it as A transpose 0 minus 1 2. Okay, 1 0 minus 3 minus 2 3 0. Okay, after multiplying it with a negative sign, what I will get here? 0 has no sign, so it is 0. Minus into plus, sorry, minus into minus is plus, so 1. Okay, minus 2 minus 1 0 3 2 minus 3 0. Now compare it with the given matrix A. See, the given matrix A, the first row is 0 1 minus 2. Here also it is 0 1 minus 2. Second row minus 1 0 3. Here it is also minus 1 0 3. And the last row is 2 minus 3 0. Here it is also 2 minus 3 0. So what we can see here, we can say that A is equal to minus A transpose. That is, I am multiplying the A transpose. After transposing the matrix, that is after interchanging the rows and columns, I am multiplying that A transpose with a negative sign. Then I will get whatever the matrix that is given in the question. That is A. So A is equal to minus A transpose. Is that clear, students? Now coming to the most important topic, orthogonal matrix. This question have been repeated many times in the previous year question paper. Okay, a square matrix is said to be orthogonal if A into A transpose is equal to A transpose into A is equal to I. Or else simply we can say that A into A transpose is equal to I. That means if it is enough, if I prove this, it is enough if I prove that A into A transpose is equal to I. Okay, no need of this entire thing. It is enough if I prove that A into A transpose is equal to identity matrix. Okay, so this orthogonal matrix is very, very important. It has been repeated many times in the previous year question paper. Okay, I will explain this orthogonal, and that means I will check whether A into A transpose is identity matrix or not. Okay, So what is the question here? Prove that the following matrix is orthogonal. The matrix is given as this 1 by 3 into the matrix, that is minus 1, 2, 2, 2 minus 1, 2, 2, 2 minus 1. Okay. Now let me start the problem. Okay, so first what should I do? I should write the A transpose here. Okay, first write down A transpose. What is first row? That it becomes column, that is minus 1, 2, 2. Interchange the rows and columns. So 2 minus 1, 2, 2, 2 minus 1. Is that okay, students? Now, what is the next step? What is the next step? I should multiply these two. A into A transpose. See, here we are 1 by 3 also. Yeah, sorry students. Here we have 1 by 3 also here. Okay. So I should multiply this A and A transpose now. Okay, so A into A transpose is equal to, what is A? 1 by 3 into minus 1, 2, 2, 2 minus 1, 2, 2, 2 minus 1. Okay, into 1 by 3. What is A transpose? We got as minus 1, 2, 2, 2 minus 1, 2, 2, 2 minus 1. Okay, so this is A transpose. Now I will multiply these two. That is multiplication of matrices. How will you multiply? I will multiply first row. Okay, see here. First row, first column. Okay, and first row, second column. Again, first row, third column. So this we have to multiply. Multiplication of matrices. I think you already know it. Okay, so after multiplying, I will multiply these two constants, that is 1 by 3 into 1 by 3, it becomes 1 by 9. Okay, now it is, see here students, be careful. So minus 1 into minus 1 plus, I'm multiplying first row with first column. I'll tell here, see, first row with first column. Minus 1 into minus 1 plus 2 into 2 plus 2 into 2. Yes. Now for the second element, I should multiply first row with second column. That is minus 1 into 2 plus 2 into minus 1 plus 2 into 2. Now for the third element, I should multiply first row with the third column. That is minus 1 into 2 plus 2 into 2 plus 2 into minus 1. Yes. Now I should multiply the second row. See here. Now I will make use of second row. Okay, multiply second row with first column. Then second row with second column. And second row with third column. Okay, that is how the multiplication takes place in matrices. Okay, so that is first, second row, first column. So 2 into minus 1 plus minus 1 into minus 1 plus 2 into 2. Now second row, second column. So 2 into 2 plus minus 1 into minus 1 plus 2 into 2. Yeah, now second row, third column. 2 into 2 plus minus 1 into 2 plus 2 into minus 1. Now, in order to get the third row, I should make use of this third row, first column. Okay, third row, second column, third row, third column. Okay, now, so now first it is third row, first column. 2 into minus 1. Don't get confused, students. Plus 2 into 2 plus minus 1 into 2. Now for this element, third row, second column. Third row, second column. That is 2 into 2 plus 2 into minus 1 plus minus 1 into 2. Yes, next. Third row, third column. Okay, so 2 into 2 plus 2 into 2 plus minus 1 into minus 1. Yes. Now let us solve this. Is equal to 1 by 9. Minus 1 into minus 1 is 1 plus 4 plus 4. Okay. This is minus 2 plus 4. Next, minus 2 plus 4 and minus 2. Minus 2 minus 1 plus 4. Here it is. Wait, let me check, student. This minus 1 second row. Yeah, this is 2. Sorry students, a small mistake. This is 2. So here minus 2 plus 4. Next 4 plus 4 plus 1. Yeah, 4 plus 1 plus 4. Next here it is 4 minus 2 done. Next here it is minus 2 plus 4 minus 2. 4 minus 2 minus 2. Here it is 4 plus 4 plus 1. Is that clear students? Now again we'll solve this matrix, which is equal to 1 by 9. Here it is 1 plus 4 is 9, 0, 0, 0, 9, 0, 0, 0, 9. This we are getting here. So I will take, this implies now it is 1 by 9. I am taking 9 common outside. Okay, then what will be the matrix here? 1, 0, 0, 0, 1, 0, 0, 0, 1. Now here 9 and 9 get cancelled. So we are left with only identity matrix, that is 1, 0, 0, 0, 1, 0, 0, 0, 1. Which is nothing but a 3 by 3 identity matrix. So A into A transpose is equal to identity matrix we have got. So the given matrix is orthogonal matrix. Therefore, the given matrix is orthogonal. Is that clear students? How to solve this? Simply we have to prove A into A transpose is equal to I. Okay, the matrix will be given as A. First find out the transpose, that is interchange the rows and columns and multiply those two matrices carefully, and the answer we should get it as identity matrix. If you get it as identity matrix, then we can say that the given matrix is orthogonal. And if you are not getting it as identity matrix, then we can say that the given matrix is not orthogonal. Is that clear students? Now coming to the next topic, Hermitian matrix. Even this topic is also very important. Hermitian. All these all these questions are been asked for 2 marks or 1 mark question. Okay, so this orthogonal matrix is asked for 2 marks. Okay, you have to prove like this. Even this Hermitian matrix, how the question will be asked is define Hermitian matrix and explain with an example. This is how the question will be asked for this Hermitian matrix. Okay, now a square matrix is said to be Hermitian if A transpose is equal to A bar. Okay, so where A bar is called a conjugate of A. Okay, let me see first what is this A bar here. Okay, A bar, for example, A is given as A plus IB. Okay, A bar can be written as, simply you have to change the sign of the imaginary part. Wait students. Okay, this A is called as real part. Small a is called as real part and this small b is called as imaginary part. Imaginary part. Okay, now how will you write A bar, that is called as conjugate of A, is nothing but simply change the sign of the imaginary part. A plus IB becomes A minus IB, that is called as conjugate here. Okay, now is that clear students? Simply change the sign of the imaginary part, then it becomes A bar. Here we have to prove A transpose is equal to A bar. Okay, so A is given here in the question. First write down what is A transpose. A transpose is equal to, simply interchange the rows and columns, that is 4, 1 minus 3i, it is 1 plus 3i and 7. Yeah, so what is A bar now? What is A bar? We have to write down A bar for this question. Okay, so A bar is equal to, simply change the sign of the imaginary part. Here it is a constant, this is a real part. Here 1 plus 3i will become 1 minus 3i. Okay, and this becomes 1 plus 3i. And this is a real part. So if we observe carefully, A transpose is equal to A bar. See, 4 4, 4, 1 minus 3i, 1 minus 3i, 1 plus 3i, 1 plus 3i, 7 and 7. All the elements are equal. So we can say that A transpose is equal to A bar. Therefore, the given matrix is Hermitian matrix. Is that clear, students? Next coming to the skew Hermitian matrix. Even this is also important. The same, define skew Hermitian matrix and explain with an example. Simple. For 2 marks or 1 mark. A square matrix is said to be skew Hermitian if A transpose is equal to minus A bar. Same as what we have seen for skew symmetric. In skew symmetric, what we have seen, A transpose is equal to minus A. Here A transpose is equal to minus A bar. Okay, let us start the problem. So first write down A transpose is equal to minus 3i. Here it is 2 plus I, minus 2 plus I and minus I. That is interchanging the rows and columns. Now I will write down A bar first. What is A bar? We have to change the sign of the imaginary matrix. Here the first element is minus 3i, so it becomes plus 3i. Second element is 2 plus I, here it will become 2 minus I. Third element is minus 2 plus I. Change the sign of imaginary part only. So minus 2 minus I. And the fourth element is minus I, so write it as plus I. Okay, now I will multiply this with minus sign. Okay, minus A bar is equal to minus of, okay, 3i, 2 minus I, minus 2 minus I and I. Now, if I multiply with a negative sign, it becomes minus 3i, okay, minus 2 plus I, 2 plus I and minus I. Okay, now observe carefully, students. If you observe carefully, this matrix and this matrix is same. Minus 3i, minus 3i. Minus 2 plus I, minus 2 plus I. 2 plus I, 2 plus I. Minus I and minus I. So what we can say here? We can say that A transpose is equal to minus A bar. Therefore, the given matrix is skew Hermitian matrix. Is that clear, students? Now coming to the next type of the matrix, that is singular and non-singular. Singular matrix. First let's see, only the difference between singular and non-singular is the determinant. Okay, if determinant is equal to 0, then we can say it is a singular matrix. If determinant is equal to 0, then it is a singular matrix. If determinant, sorry, here it is not equal to, I am sorry, students. Here it is not equal to, okay. If determinant is not equal to 0, then it is called non-singular matrix. Okay, so here is the example for you. Okay, first let us find out the determinant. Let me check whether the determinant is equal to 0 or not equal to 0. Then we can say based on that whether it is a singular matrix or non-singular matrix. Okay, so first write down the sign here, plus, minus and plus. Okay, so determinant A is equal to 1 into corresponding row and corresponding column, it becomes minus 3 plus 4. Next, minus 1 into corresponding row and corresponding column, minus 2 plus 4 plus 1 into minus 2 plus 3. Okay, let me calculate this. Okay, it is 1 into 4 minus 3 is 1, minus 1 into 4 minus 2 is 2, plus 1 into 1. So it is 1 minus 2 plus 1, which is equal to 0. Okay, so here the determinant is 0. So we can say that the given matrix is singular. The given matrix is singular. Even this is very important. Is that clear, students? Even this is important. for 2 marks or 1 mark. Okay, he will give one matrix like A is equal to so and so matrix. You have to prove whether it is a singular or non-singular according to the based on the question. Now, coming to this unitary matrix. Unitary matrix is a square matrix in which a to the power of theta into a is equal to a into a to the power of theta is equal to I. Okay, where a to the power of theta is nothing but a transpose whole bar. That means we have to first transpose the matrix, then we have to find the conjugate. Bar is nothing but conjugate, right? So a to the power of theta. Simply if I prove like a into a to the power of theta is equal to I, it is sufficient, Nana. If I prove like this also, it is enough. A into a to the power of theta. Okay, so here is the given matrix for you. Let us see. Prove that 1 by 2 into this is a unitary matrix. This has been asked 3 times. 2002, 10 and 22. Okay, now let's start the problem here. So I will prove a into a to the power of theta is equal to I. This I will prove. First, let me see what is a to the power of theta. Okay, a to the power of theta is nothing but a transpose whole bar. That means first I should find out a transpose. Okay, so a transpose is equal to, what is a transpose? 1 by 2 into 1 plus I, 1 plus I, minus 1 plus I, 1 minus I. So this is a transpose. Let me check students once again. First row, first column, second row, second column. Yeah, now we should make conjugate for this because a transpose whole bar, which gives you a to the power of theta. Okay, now I will conjugate this. That means simply we have to change the sign of the imaginary part. Is equal to 1 by 2 into, change the sign of imaginary part, that is 1 minus I, 1 minus I, minus 1 minus I, and this is 1 plus I. That's it. Now I will multiply a into a to the power of theta, and I should check whether I am getting it as a identity matrix or not. Okay, so a into a to the power of theta. So what is a here? 1 by 2 into, a is nothing but the given question. 1 by 2 into 1 plus I minus 1 plus I, 1 plus I, and 1 minus I. Now what I got it as a to the power of theta into 1 by 2, 1 minus I, 1 minus I, minus 1 minus I, and it is 1 plus I. Is that clear, students? Till now? Yes. Now let us multiplication of matrices. Let us do multiplication of matrices here. So the constants will be, that is scalar factor. We should not call it as constants. This 1 by 2 and 1 by 2, we call it as scalar factors. So multiply those two scalar factors, it becomes 1 by 4. And first row, first column. Okay, so 1 plus I, first row, first column. 1 plus I into 1 minus I plus minus 1 plus I into minus 1 minus I. Now coming to the second element, first row, second column. That is 1 plus I into 1 minus I plus minus 1 plus I into 1 plus I. Yes. Now coming to this element, third element, second row, first column. Okay, 1 plus I into 1 minus I plus 1 minus I into minus 1 minus I. Now second row, second column, 1 plus I into 1 minus I plus 1 minus I into 1 plus I. Is that clear, students? Now let us solve this. We know that here we know that I square is equal to minus 1. This we already know. Okay, now we'll make use of this. So 1 by 4 into 1 plus I into 1 minus I is a plus b into a minus b. That is a square minus b square plus minus 1. We have to multiply these two. Second, minus 1. Okay, here it is 1 plus I minus I minus I square. Okay, coming to the second element, it is 1 plus I into 1 minus I, that is a plus b into a minus b. a square minus b square, that is 1 minus I square. Okay, plus minus 1 minus I plus I and plus I square. Yes. Now coming to this third element. Again a plus b into a minus b, that is a square minus b square. Okay, plus minus 1 minus I plus I minus into minus plus I square. Okay, now here again it is 1 minus I square, a plus b into a minus b, plus 1 plus I minus I minus I square. Yes. Now I square is equal to minus 1, right? So here it is 1 minus 1 plus this plus I minus I will be get cancelled, and I square is already minus 1, minus into minus plus, so 1 plus 1. Here, see here, sorry student, here it is 1 plus 1, because I square is already minus 1, we have minus 1, so it is 1 plus 1 into 1 plus 1. Yes. Next coming to the second element, here again 1 plus 1, I square is already minus 1, so we have minus, so minus into minus plus, plus this minus I plus will get cancelled, here it is minus 1 minus 1, I square is minus 1. Next, here is again 1 plus 1, okay, plus minus I plus I will get cancelled, minus 1 minus 1. Now here it is 1 plus 1 again, plus I minus I will get cancelled, 1 plus 1. Yes. Now what you are getting here, 1 by 4 into 2 plus 2 is 4, 0, 0, 4. After solving we'll get like this. Now I will take 4 common outside, that is 1 by 4 into 4. What you are left with, 1, 0, 0, 1. Now 4 and 4 will get cancelled, and the final answer is 1, 0, 0, 1, which is nothing but identity matrix. Is that clear, students? So what we can say, that a into a to the power of theta is equal to identity matrix. Therefore, the given matrix is unitary. Just please be careful while performing the multiplication of matrices. Only that step you should be careful. Okay. Small mistakes can be made, but just correct it while solving it. Correct those mistakes and do it again. Is that clear, students? So these are the types of matrices. Among these all types of matrices, the most important types of matrices are orthogonal, Hermitian, skew-Hermitian, singular and non-singular, and unitary matrix. These 5 matrices are very important. These 5 matrices have been asked in the previous year question papers. For more videos and problems, please do subscribe the channel and download Sankalp Study Success app. Thank you, students.